So this question comes from 5.2's question 11 in the My Open Math. And it says, consider you have this geometric series, 2 times the cosine of 4 to the nth power. And it says, if you write it in the standard form for a geometric series, so this is the standard form for a geometric series. And then it wants us to first pick out A and R. So sometimes we have to manipulate it a little bit to see what A is and what R is, but in this case we don't. A here is 2, and then R is cosine of 4. So we plug those in the blank. And then it says determine whether the series converges or diverges. And so in order to determine that, what we need to look at is the absolute value of R. And if the absolute value of R is less than 1, or if you don't want to use absolute value, you could say that the value of R is between -1 and +1, then the series will converge. And that test that you're going to use is it's called this test that we're doing is the geometric series test. So if we put the cosine of 4, making sure we're in radian mode, that 4 is a radian number, we end up with this number, -0.65, which is between -1 and 1. So then, since that is true, then we say that this series will converge by the geometric series test. And then it says, if the series converges, give its exact value below. If it diverges, enter DNE. So to find the series converged, if you have it in this form that looks like this, which we do, then we can say that it is equal to the sum of the infinite series, and it will be a sub 1, so the first term, divided by 1 minus r. And so the first term here, if you plug in 1 here, the first term would be 2 cosine of 4 to the first power. So just this would be 2 cosine, 2 cosine of 4. And then it would be 1 minus the cosine of 4. And we'll just keep it in this exact form. We don't want to put a decimal in their approximation unless it asks us to. So this is what it would converge to. This is its exact value. So since it's its exact value, we leave it in this form.